Recording, then we're good. Here we go. So today we're starting limits, which is pretty exciting. Okay, so we're starting limits, which is a calculus concept. Okay, it's the hardest part of calculus, the weirdest part. Once you learn the other two topics, I'll write them over here. You learn limits in calculus. You learn derivatives in calculus. And then you learn antiderivatives in calculus. And antiderivatives are another thing called integrals. And really, there's only three topics. So calculus really only has three topics in AB calculus. Limits is at the beginning. So this is the start. And it's the weirdest. And then you'll be very good at derivatives and you'll be very good at integrals. And integrals are going opposite of derivatives. And then we have applications of all these things. And that's pretty much all of calculus. It's kind of cool. Derivatives are related to slope, like algebra 1. And antiderivatives are related to area, which is kind of like geometry. But what if you have a shape that looks like this? So say you have a parabola that looks like this. What's the slope of the parabola? Well, the slope at different spots is different. So like this slope is going up, so the slope is positive. This slope is flat, so it's 0. And the slope over here is negative because it's going down. So we need a formula and an equation for the slope. Then that's derivatives. And then antiderivatives, you're basically, they want you to find the area. Now, if it was a trapezoid or it was a rectangle or a circle, we know the formula. The formula for a circle is actually derived with calculus. HL math is where you learn that. But if you want the area between, like something like this, where it's curved in a different way than a circle, then we need to know how to find the area. And the area would be for antiderivatives, which are called integrals. So we learned some techniques on how to find them. But it's very good. You'll be very good at calculus. Calculus is quite an enjoyable topic, but limits are a little weird. So I'm going to show you our favorite ones of limits. We're going to show you that first. Monday, which is tomorrow, I'm going to show you the other types of limits. There's friendly ones and there's weird ones. I need to figure out a way that I can be videoed because I have to point with my fingers and I'm not sure that I can really point effectively with my tablet. So we'll see what that's like. Okay, but let me show you this. So we're going to start with 12.4. We're not starting with 12.1 because 12.1, the limits are a little bit weird. And you'll like the limits in 12. Okay, so the first thing we're going to talk about is just the basic limits. So what we're doing is we're doing limits as x approaches infinity, okay, of an equation. So let me show you one that you'll recognize from before. So let's say we have 3x to the fourth minus 5x plus 6. Okay, this is a new notation. Okay, notice there's no equal sign here. I'm going to write the word of. It's the limit of. It's not the limit equal. Okay, so this is your notation. Okay, and basically the idea is this. So this is I'm going to call this calculus notation. So this is the calculus notation, but we had old notation. Okay, so we had old notation, and let me tell you what that was. Our old notation was f of x equals 3x to the fourth minus 5x to this plus 6. And this was in chapter 2 this year. And it was called end behavior. Okay, so it was called end behavior. Okay, so end behavior. So I don't know if you remember this. This was back in chapter 2, long time ago. Okay, and the way we wrote it is we wrote it like this. As x approaches infinity, what does f of x approach? And as x approaches negative infinity, what does f of x approach? Okay, so we had prior notation, but we need to convert it to calculus notation. Okay, so this is our old notation, probably algebra 2 and math analysis, the first time we saw it. Okay, but we want to talk about what it's going to look like in a calculus format. We're just trying to get you used to the ideas. Okay, so what end behavior was, remember we used like the biggest one. And we said, okay, what happens if you substitute an infinity in here? 3 times infinity to the fourth is like 3 times a billion to the fourth. And the answer was positive infinity. Okay, and then what happens if you're thinking negative a billion to the fourth times 3 is, and then the other terms were not important. And then that was positive infinity. Okay, now this was informal. Okay, so we were not writing it the formal way. We're not writing it the official way. We're trying to get an idea of what's going on. So let me show you how to write those two things in the calculus way, just so you can kind of get used to the different notation. And then I'm going to show you an official method to actually get the answers of infinity or negative infinity, or we're going to have other answers in these problems too. Okay, so limit as x approaches infinity, and then you put the equation next to it, and then the equal sign. Okay, so the way you say this is you say limit of. Okay, so this of, so that's what you write. You say limit of 3x to the fourth minus 5x plus 6 as, so this you say as x approaches infinity. Okay, so that's how you say it. And this line right here, you say approaches. Okay, just so you can kind of think of it right in your head as you're learning this calculus notation. And then this answer would be positive infinity. And then also limit as x approaches negative infinity. And the x approaches negative infinity is physically like underneath the LIM. Okay, so if I was on lined paper, I feel like the 3x to the fourth minus, well, it's kind of all on the top of the paper. Okay, but this would also be positive infinity. Okay, now this is, I'm going to put this right here. This is correct notation, but informal method. Okay, so I'm going to show you the formal method that we're going to practice today. Okay, and then the formal method will help you with other things as well. Okay, so this is the old notation. This one's new notation. Okay, new notation. Okay, this assignment will be kind of fun. And then the one for Wednesday, the one that you're doing on Wednesday, it's a little confusing. Okay, so you're going to probably have a lot of questions on that one. This one, you won't have as many questions. Okay, so let me show you what's new. Okay, so our 12.4. Okay, so what we have is we have limit as x approaches, and then it's going to be infinity or negative infinity, because what we're doing is we're doing infinite limits. Okay, we're doing limits at infinity. I think they call it limits at infinity instead of infinite limits, because infinite limits implies the answer will be infinity. Okay, so limits at infinity. So basically you're approaching infinity. Same thing as the as x approaches infinity that we've done before. And then most of the time what they have is they have a rational expression. Okay, so they have something like this. And you've done this before. So you did this before in the chapter, it was chapter 2 at the end when we were graphing rational functions, but we're going to do it the official way instead. So 3x to the fourth minus 5x plus 6, I'll put that. And in the denominator, I'm going to have something else. So I'm going to have 8x to the fourth plus 3x squared minus 4. Now, unofficially, my brain thinks, okay, 3x to the fourth is the dominant term. That's the important term. And the 8x to the fourth is the dominant term. And in algebra 2, they said, hey, just take the coefficients of the highest powers. 3/8 is the answer. Okay, so 3/8 is the answer to this, but we're trying to show the official calculus work. So we know the answer, but we have to figure out how to get there legally. Okay, now the reason we need to know how to get there legally is what if there's an e to the x in there? What if there's a sine x? What if there's a cosine x? What if there's a logarithm? Your polynomial method's not going to work. Okay, so we're going to show you the official way so you have some other ways to handle this. Okay, so let me show you, let me give you instructions. So number 1 is you're going to locate the highest power of x in the denominator. Okay, so in the denominator, not in the numerator. So you look here, and I feel the highest power of x is x to the fourth. Okay, so the answer for this one is x to the fourth, not 8x to the fourth. That'll make your problem a little more complicated. Just pick x to the fourth. Step 2, you're going to divide each term by x to the fourth, the highest power. Okay, so divide it by that. Okay, then you're going to reduce, and I kind of think of this in 3 steps, 2, 3, and 4. Okay, so you're going to reduce, and then you're going to find the each limit. And I'll show you what that is. Okay? So that's the plan. So And then I'm going to also tell you why I can legally do this, but first I wanted to show you what it looks like. So first of all, you're going to draw like a big fraction. Okay, so it's going to be a big fraction. So I'm going to put 3x to the fourth minus 5x plus 6 in the numerator, but leave a denominator because I want to divide by x to the fourth. And then 8x to the fourth plus 3x to the second minus 4. Okay, I'm going to change color so you can see it better. So we decided we're going to divide everything by x to the fourth. Okay, so you're going to divide everything by x to the fourth. And again, this is the official method. Okay, so there's other methods, but they're not official. So this is the official method on how to do polynomials. Okay, now, if you still have an x in the problem, and I have what? X to the fourth, x to the fourth, x to the fourth. I got a bunch of x to the fourth. So I've got x to, ooh, I should put the chat up so in case you guys see my error. But did you guys see my error? I have an error. Can you see what it is? Anyone see my error? Okay, this is not an error, but it looked like the wrong number. So I'm going to change that. It looks like a 4. Yeah, I put x squared. What the heck was I thinking? Okay, so take that away, and that's x to the 4. Okay, now, if you still have an x in the problem, you still need the word limit. Okay, so that's why I write down instead of sideways, because I often forget to write the limit. And then I look and I say, look, there's all x's there. I need to carry down the limit. As long as there's an x still there, I need to know what it's still approaching. Okay, so you do have to bring it down. Okay, then you reduce each one. So this one I call the divide step. Okay, and you guys aren't taking a test on this year, but it's better to practice it the way that you're going to be expected to do it in the future. Okay, now you do the simplify step. So let me call this simplify step. So this is usually where people miss out on partial credit because they do like 2 steps in one. Okay, so this is what? 3 minus 5 over x to the third plus 6 over x to the fourth divided by 8 plus 3 over x to the second minus 4 over x to the fourth. And then you have limit as x approaches infinity. And the same thing would be if it approached negative infinity. Okay, and now what you individually do is you individually look at, I'm going to highlight them. You're going to individually look at the terms with the x's. So I have 4 of them. So I'm going to look at those individually. Okay, and then I'm going to write over to the side the idea. Okay, so this is step 4. And basically what you're saying is the limit as x approaches infinity of a plain number. So we're just going to put a number sign. A number over x to a power. Okay, so we'll call it x to the k, where k is actually anything greater than 0. So where k is 0. Okay, I'm going to show you what that equals. Okay, and that's actually true. I'm going to put or x approaches negative infinity. It's actually true for each. Okay, so what I want to show you, I'll look and then I'll write the formula for you. But I like to think of it as a how. I don't like to memorize formulas. Okay, so let me show you the 6 over x to the fourth. Okay, so what I imagine is 6 over, so this is what I'm imagining in my head, 6 over infinity to the fourth. Okay, now when you're doing these, what you're thinking on the top is donuts, and at the bottom is people. This works really well with infinite limits. Okay, so donuts and people. So what if you have 6 donuts and like a trillion people? Okay, so 6 donuts and a trillion people. How many donuts do you get? So what do you think? Anyone know? You have 6 donuts and you have a trillion people. How many donuts per person? Almost none. Exactly. So this approaches 0. Okay, so this is the key. If you have a non-zero, well, even 0 on the top. So if you have any number at the top and you have x to a positive power, it turns out that this is 0. I call it a crumb if you have me for HL math. And I'm not sure if Miss Perfection and Miss Herzog call this, but think of it as a crumb. Okay, so it's a crumb. You get a little tiny piece of donut. Okay, so how we write that over here is you don't write what I wrote on the side. This is part of my ideas. Okay, my steps. This is start of my steps. So this the left side looks like the homework problem. Okay, so what you do is you draw an arrow. So I draw an arrow that looks like this. This is official calculus arrow. So what if you have 6 people and you have 1,000,000,000 to the 4th donuts? You practically get 0. So you put a 0 there. Okay, and this is to find each limit. Okay, now the 5 over x to the 3rd. So 5 over x to the 3rd, this part also is 5 people and 1,000,000,000 to the 3rd donuts. I'm still getting a crumb. And if you do it right, all the ones with x's turn out to be 0, except sometimes like that 3 in the front, this blue one, sometimes the 3 in the front has an x or an x squared, and then we have to deal with that. So I'll show you that as a different problem. Okay, but 3 doesn't have an x, so x approaching infinity doesn't change anything. Okay, so these turn out to be what's left because all these other pieces are 0. Okay, but you want to get used to not just crossing them out, but thinking about the donuts. So I've got 4 donuts, right? I have 4 donuts. I have a 1,000,000,000 to the 4th people. That's 0. 3 donuts, 1,000,000,000 squared people. That's 0. I'm getting crumbs. And then your answer is 3/8, which is your algebra 2 method. Now, do I need the limit? So let me write the 3/8. The answer is there an x? If there's no x, you no longer need the limit. So since there's no x, you don't write the limit anymore. Okay, so let's write a little note over here. When there are no x's left, then you write no limit words. Okay? And then I just usually put an equals. But I mean, you could put an equals in the front of every step as you're going down. Okay, so that's the plan. Now, if this problem were a negative infinity, what's negative infinity to the 4th? Well, it's still 1,000,000,000 trillion people. So I have 4 donuts and 1,000,000,000 trillion people. I deal with the negative later in the front. You know, so you still end up getting 0. So it turns out to be very similar. Now, what's interesting later is you're going to have, well, what's sine of infinity? What's cosine of infinity? What happens as you approach infinity? What's e to the infinity? What's e to the negative infinity? And those two things are different. And so that's why we need to give you some structure on how to apply problems in the future. Okay, so this is the formal way. This is the way we want you to practice. We're not going back to algebra 2, so we don't want you just to do it the algebra 2 way. Okay, you're trying to get familiar with limits. Okay, okay, so let's do another one. Now, there is another one that I saw in the book that's kind of towards the beginning. So I'm going to show you that one. Here, let me call this example 1. Okay, so some of the questions at the very beginning of your homework are already divided for you. So it's a little weird with the way I usually give notes. Okay, so let me show you one that's already been divided by. So x approaches negative infinity. And then you have 4 over x to the 2nd minus 3. So do you see how it's not really in like quotient form? It's not something at the top divided by something at the bottom. So this is like already simplified. Okay, so this one's already ready to substitute the negative infinity in. Okay, so you can think of it over here as, so I'm going to put not in this format. Okay, and so maybe I could just do it directly. So what's 4? So this is what's going on in my head. What's 4 over negative a billion? We'll put 10 to the, we'll do a million. 10 to the 6th. So what's negative 10 to the 10? Oops. Let's try that again. So what's negative 10 to the 6th to the 2nd? So I basically have 4 donuts. And I have 10 to the 12th people. I mean, that's a huge number, right? That's like 12 zeros. 12 zeros. Hold on, let's see. 3, 6, 9, 12. So 12 zeros. So I've got 4 donuts for 10, I don't know, 1,000 trillion people. I don't even know if that's a word. Okay, so this is a trillion, 1,000 trillion. I think that's it. So I don't know what 1,000 trillions are. But anyway, so we have a whole bunch of people. How many donuts? That limit is 0. So you put the arrow 4 over. It doesn't matter that it's negative infinity. We still get a 0 there. And then underneath, we get just 0 minus 3, which is negative 3. Let me change it to red because I'm just using that red color. And then there's no more x, so you don't need the x anymore. me show you another one of those, and then I'll show you the divided by ones. So there's only two, 9 and 10. So this one's like 9 and 10. So if you have limit as x approaches positive infinity, and I don't know how to describe the fact that it already looks divided by to me. So say you have 4 over 3x, negative 4 over 3x, plus 7. So I'm really trying to think of myself substituting in this infinity, just like the other end behavior. Okay, so I'm thinking infinity, 3 times infinity is like, I've got like 3 and a bunch of zeros. I've got negative 4 donuts, but negative seems weird for donuts, so I'm going to put the negative in the front. This is kind of what's going on in my head. Because remember, you're trying to train yourself to think of what limits mean so that when the limits get more complicated in regular calculus, you'll be able to figure them out. So I've got 4 donuts. I have this many people. So donuts over people is a good way to think of it. So I've got 4 donuts and that many people. So I basically get a crumb. Okay, and if it says a limit in the front, then you don't have to draw an arrow. But this one, it's hard for me to put equals 0 because I do get a crumb. So that's negative 0, which is still 0. But in a limit, over here, you just put approaches 0. The arrow is the approaches. And then the answer is 7. Let me show you another divided by 1. And then we're going to talk about horizontal asymptotes, the official way. And you would need to use the official way in calculus if it asked you find the limit and you were on the written part, then you would want to find it the official way. If it was multiple choice, you can use an unofficial way. And then for horizontal and vertical asymptotes, those are related to limits as well. Okay, but again, this is the weirdest part of calculus. Okay, so those are the ones above. Example 2 and example 3 are like 9 and 10. Okay, so example 4, we're going back to one of the other ones, and we'll have the limit as x approaches negative infinity again. Okay, so we have 2 minus 6x over 5 plus 4x, something like that. Looks like a quotient. Looks like my form. Polynomial at the top, polynomial at the bottom. So it's in the right form. So my plan is going to be to divide by x to the highest. Oops, that's not equal highest. X to the highest. I can't spell the word highest. Okay. Highest power in the denominator. Okay, and I'm going to show you one later that the exponents do not match at the numerator and the denominator. Okay, so what's the highest power? X. So you're going to make that big fraction. You're going to show that divided by step. Okay, you're going to show the divided by step because you're doing it the official way. We're trying to get you a method that's more official than just our estimates. Now, I do like dominant term. Dominant term is what we showed you with end behavior earlier, and I use that all the time. But I want to show you the official way as well. So if a problem gets complicated and you can't use the dominant term, then you can use another one. Okay, I'm dividing by x, and the reason I'm dividing by x is because of this x right here. Okay, so x to the highest power in the denominator is that. So I'm going to divide every term by x. And then you have to ask yourself, do I still have an x in the problem? I do, so that's why I need the limit as x approaches negative infinity. I need to keep that x approaching negative infinity until I have no x's left. Okay, so you have to simplify. So don't forget the simplify step. I was about to do the cross out step, finding the limits, but I'm going to simplify first. So that's 2 over x, that's minus 6. This is 5 over x, and this is plus 4. Do I still have an x? I do, so I still need the limit as x approaches negative infinity. Okay, now I find the limit. So I say, oh, I've got 2 donuts. And what am I substituting in for x? I'm substituting in negative a trillion. So what's 2 donuts over negative a trillion? You know, or however many zeros you want. So that's not really a trillion. One more 0 is a trillion. Okay, so you're substituting that in. So you can kind of pull the negative out in the front. The negative is not really important on these. There's some questions where it might turn out to be important, but mostly not. Okay, so 2 over infinity is 0. Negative 6 is just negative 6. 5 over infinity is 0. 5 donuts, an infinite number of people. You basically get a crumb. The arrow means you're approximately getting a crumb. The word limit means you're approximating. Okay, it's what you're approaching. And then the answer is negative 6 at the top, 4 at the bottom, which I should reduce to -3 over 2. Okay. So my favorite are the infinite limits. Kind of nice. The algebra is kind of nice when you're working these out. It turns out pretty good. Okay, questions so far? A 100 trillion. Okay, cool. Did I have my zeros wrong? 1, 2, 3, 1, 2, 3. Because it's 12, right? 1, 2, 3, 1, 2, 3. I don't think so. I think it's 1,000 trillion. Right? Because it's 12 zeros. Right? A 10 to the 12th means 12 zeros, and then a 1 sitting in the front. It doesn't matter. Doesn't matter. So the point is the same, right? It's a crumb. It's a little tiny crumb. Oh, it does. It does. Good point. Let's move that negative. You want to move the negative there? Do you like that better? And honestly, Shirley, it's more likely that I made an error than you made an error. So I was like, oh no, I think I was right, but I make mistakes all the time. So no problem. Okay, so I moved that negative because it looked like there was a space and not a minus sign. Okay, so I changed that. Okay, so that's the answer. Okay, so let's do example 4, but we're going to title this new. It's going to be called horizontal asymptotes. Horizontal asymptotes. Okay, so I'm going to just draw a little picture, but we're not going to draw a picture. This is just to give you the idea. Okay, because really we're just trying to get you introduced to this. We don't need you to be an expert this year. Okay, say you have this problem right here. Okay, I'm going to call this 4. Okay, and you have a graph. Okay, so say I have this graph right here. Okay, so just take some time to draw that graph for me. And no picture will be needed on the problems. It does say in the book, like, use a graphing calculator to draw it, but I don't think anybody cares if you do that. Okay, so take a look at this. Okay, now the end behavior idea. So this is the old way. So let's just look at the old way, and then we'll write it with the new way. So the old way was to find a horizontal asymptote, you use end behavior. Okay, and end behavior is the same as limits at infinity. Okay, so as x approaches infinity, what does f of x approach? And as x approaches negative infinity, what does f of x approach? This is what gives you horizontal asymptotes. Okay, so basically what we're saying, and you're going to have to follow my pen line, okay, because I'm going to be in action. So we'll see. Let me do it with highlighter. I'll go slow, okay? So I'm going to go really slow. So look at the graph. Okay, so look at where my yellow is coming. Okay, so see my yellow. I'm making x be 3, x is 4, x is 5, x is 6, x is 7, x is 8, x is 9, x is 10, x is 20, x is 30, 30, 40. What is happening to my yellow line as I go farther and farther to the right? What a limit is going to mean is what y value do you get close to? So it's basically hugging this asymptote. Okay, so the limit in this case, and I'll write it down here at the bottom, the limit is 4 as I go to the right. Now, positive infinity was to the right, and negative infinity was to the left. Almost always, the right and the left give you the same answer. Okay, so it's very rare. It's very rare that you won't have that you'll have different answers, but it's possible. So we'd rather have you try both of them. And there's some new problems in calculus where they have an E in the problem, and definitely the left hand and the right hand infinite limits are different. You'll have a different horizontal asymptote one way, and a different horizontal asymptote the other way. Okay, so I'm going to, in my blue, I'm going to try to approach negative infinity. So over here is x is -1. So look at my little blue dot. X is -2, -3, -4, -5, -6, -7, -8. And this is approaching as I go to the right or to the left. As x approaches negative infinity, which is all the way to the left, what's the y value getting close to? And the y value is getting close to -1. Now, what are the equations of those asymptotes? So if I get a 4, that means the equation of the asymptote is y equals 4, a horizontal line. So this right here would be the horizontal asymptote. Now, I sometimes call that a right horizontal asymptote, but that's not an official name. It's just a name I came up with when I was teaching calculus a couple years ago. And then this one would be y equals -1. Okay, and that's a left horizontal asymptote because I was going on the left side. Okay. Now, in calculus notation, okay, so in calculus notation, I'm going to write limit as x approaches infinity of f of x equals 4. So that's what it looks like, and that means y equals 4 is the horizontal asymptote. And limit as x approaches negative infinity of f of x equals -1 means the asymptote is at y equals -1. Now, how do I find these limits as x approaches infinity and x approaches negative infinity? We use the method of examples 1 through 4, because we're going to do it we're going to do it algebraically. We're not doing it graphically today. Tomorrow's graphically, and that's what's a little weird because we're not as good at graphs as we are at algebra. Hey, you guys are like super studly, amazing students at algebra, and graphs sometimes we just don't practice graphs enough. You know, your math teachers like me were better at all the little details in the algebra stuff. And it's very hard to communicate the graphical to a student, right? Because we're seeing different things. What are we pointing out? What are we seeing? So we'll see how I can figure out how to do that tomorrow. So tomorrow night, I'm going to try to do it. So I'm writing on a dry erase board so that I'm videoing me writing on a dry erase board. And then I can point to where the limits are and use my hands. We'll see. We'll see. I'm not sure I can figure that out. Okay. Okay. So this is the calculus notation just for graphs, okay? So this is just graphs. So I'm going to put the idea of graphs. Okay, but we're not doing graphs. We're going to do it algebraically. Okay, so let me put algebraically. Okay, so this is going to be the method for the homework. Okay, so what your job is going to be to do is if it says find the horizontal asymptotes. Okay, so find the horizontal asymptotes. This is your plan. Your plan is you need to find the limit as x approaches infinity of f of x, and you're supposed to get a number for it to be a horizontal asymptote. Okay, and you're also supposed to find the limit as x approaches negative infinity of f of x. And that could be the same number or a different number. So I'll put number 1, number 2, I guess. So it does not have to be the same number, but it almost always is. So then people only look at infinity, and that's why they made a new calculus problem where they ask you for the asymptote, and there's different ones on each side, and then you miss it because you're only ever used to trying infinity. So on my old test, I would give extra credit if they found the infinity and the negative infinity, even though it turns out to be the same answer. So it seems like a waste of time. It's not a waste of time with E. It's not a waste of time with sine and cosine, not a waste of time with logarithm. Okay, so it only seems like waste of time because we're only learning polynomials right now. Okay, so let me show you what the problem is. Okay, so let me show you what an example is. So this is example 5. And this one, it doesn't give you a limit in the problem, but it's your job to use a limit to solve the problem. So this is an old problem that you would have done. 3x squared minus 5x plus 6. In the denominator, 4x squared plus 3x minus 2. And this is going to say find the horizontal asymptote. Now, we taught you the algebra 2 way earlier in the year. Okay, because we hadn't taught you limits yet. Okay, but now we want to teach you the calculus way so that you do it the way that that you're supposed to do it in an official calculus method. We were just trying to give you like the idea of how to do it before. Okay, So find the horizontal asymptotes. Whenever I see horizontal asymptotes in calculus, in non-calculus, is I always think I need to write a limit. Okay, so I need the limit as x approaches infinity. And I write the equation. Don't put equals the equation. It's an of the equation. Okay, so don't put an equal sign in between the limit. Okay, so this is what you have. Okay, so this is going to be for the right side. So if there was a different right side and left side asymptote, if they're different numbers, this is the right side because I'm approaching positive infinity. I'm thinking, what if I plug in a billion? What if I plug in a trillion, 100 trillion, 1,000 trillion? I keep plugging numbers in. Now, you and I know, you learned algebra 2, you're already good at that. You're like, oh, just look at the 3x squared, look at the 4x squared. They reduce, they give you 3/4. That's good enough. But what are we going to do if it's a different function? So we're trying to practice. And we're trying to do the official method in this one instead of just an estimate. Okay, so what we're going to do is how do you find an infinite limit? So you're going to divide by x to the second. Now, what legally allows me to divide by x to the second? What you're actually doing is you're dividing the top and the bottom by x to the second. But what makes it legal? Well, what makes it legal isn't that officially multiplying by 1 over x to the second and 1 over x to the second? And can't you multiply? It's like conversions in chemistry. You're allowed to multiply a numerator and denominator by the same object. Okay. Okay. So let's see. So this one you get 3x squared minus 5x plus 6 divided by, and then a big divided by 4x squared divided by plus 3x minus 2 divided by. Okay. And then you put in x to the second. Oh, x to the second, right? That was your highest power, x to the second, except my big divided by is bad. I need individual divided bys, not a big divided by. Okay, divided by. And then I'm going to put x to the second, x to the second, x to the second. We're trying to do it the official way. So you still have x's, so you still need the limit. Then you reduce. So that's 3 minus 5 over x plus 6 over x to the second divided by 4 plus 3 over x minus 2 over x to the second. You write your limit because you still have an x in the problem. And then you look and you say, what's 5 donuts and a trillion people? So that's 0. 6 donuts and a trillion squared people? That's 0. What's 3 donuts and a trillion people? 0. 2 donuts and a trillion squared people? Okay, that's still 0. And so my answer is 3/4. Now my limit's 3/4. So that's the limit, right? I could put equals 3/4 over here maybe. Okay, but what's my asymptote? The question was, what is my horizontal asymptote? So my horizontal asymptote is y equals 3/4 because I need it to be a horizontal line. And asymptote's spelled like this. Okay, and I do need to check the x approaching negative infinity. But for this particular problem, it's going to be super annoying because you're like, well, Miss Nichols, I got the same answer. So what a waste of time that felt like. But remember, I'm trying to train my brain to look at both sides, even though sometimes, coincidentally, in the polynomial questions, you get the same answer for both. But when am I going to ever check negative infinity if I don't start now? So you're like, okay, this is boring. I'm doing the same exact thing. You're feeling like so stupid. You're like, really, Miss Nichols? Why am I doing this again? Okay, and you're doing it again because you want to practice. What if it was e to the x? What if it was something different? Okay, I need to know that both sides might not give me the same answer. Although both sides are going to give you the same answer, probably in almost every problem of your homework or the homework that's related to this. Okay, so divide them all by x squared. You're like, I did this already. That's why I give extra credit on the old test for this, because it's like, really, this is so boring. Okay, so you do that, and then you have to do, that's your dividing step, right? That's dividing step. And then you need your simplify step, and then you need your limit step. Okay, so this one is 3 minus 5 over x plus 6 over x to the second. And in the denominator, that's 4 plus 3 over x minus 2 over x to the second. And then you have the limit as x approaches negative infinity. This goes to 0, this goes to 0, that goes to 0, that goes to 0, and you get equals 3/4. Maybe I put that to the side so that I can write y equals 3/4 as my horizontal asymptote. And usually limits, you don't want to put y equals, but the answer is y equals. But we're putting y equals here. And this happens to be the left side horizontal asymptote. And the one above was the right side horizontal asymptote. But in many polynomials, if you have a polynomial at the top and a polynomial at the bottom, you get the same thing for the right and the left. Okay, so all I need to show you is two weird ones, and we're done. Okay, so two weird ones, and then we're done. Any questions so far? Let me do the chat, see if anybody has any questions. Am I going too fast? Am I going too slow? Usually I'm going too fast. I think that's why 16 out of the 24 people like to do non-live videos when the people who kind of voted. Because I'm thinking that either I go too fast for half the people and I go too slow for the other half the people. Like pause. You can't really pause when it's live. And maybe Sunday's a bad day, but that's how we planned it. So maybe Mondays at 3:30 I could do a video. And then people could watch the video at 3:30 if they wanted on Mondays. And then do another one on Tuesday night. I don't know. We had originally planned for Sunday, but I didn't think about the fact that maybe students wouldn't want it on Sunday. So, and only some people want to watch the live videos anyway. Okay, so no questions so far? Okay, so let me show you the weird ones. And what example was that? That was example number 5. Okay, so let's do example 6. Okay, so example 6. What if you have a limit as x approaches infinity or negative infinity? Doesn't actually matter which one. Let's do negative infinity. And I have 3x to the 4th minus 6x plus 7 divided by 6x to the 5th plus 2x to the 4th minus 6. Okay, so what you do is you say, oh, I have a limit as x approaches negative infinity. So I want to divide by the highest power of x in the denominator. So you're going to divide everything by x to the 5th. So what legally allows you to do that is basically what you're doing is you're distributing this through each of them. Okay, but this is in my head. I usually don't do this. I just do the division. Okay, so the division is the way most people make it look. Okay, so the division, let me show each term individually. Now, like I said, you are allowed to divide by 6x to the 5th, but the numbers get worse. So I like to just divide by the x part. Okay, but what allows you to distribute is legally is that you're doing a conversion factor. You're really multiplying by 1. Do I still have an x? I do. I still need my limit. Limit as x approaches negative infinity. And then I reduce. So that's what? 3 over x minus 6 over x to the 4th plus 7 over x to the 5th. Divided by 6 plus 2 over x plus minus 6 over x to the 5th. Do I still have an x? I do. I need my limit as x approaches negative infinity. Remember, there's no equal sign in between the limit and the function. Okay? The equal sign would be after if you're going to do an equal sign. Okay. Donuts over people. I've got 3 donuts. I have negative a billion people. Okay, so I have all my negative a million people. So I have I think 3 donuts, a billion people. I'm getting a crumb, so that's 0. 6 over a billion to the 4th people, 0. 0, 0, 0. If the x is in the denominator and there's a number in the numerator, whether it's positive or negative infinity, those turn out to be 0. But you really want to put that in your mind of why it's 0 so you can remember for next year. So I don't have anything left at the top. So all those are zeros. So my answer is 0 over 6. And 0 over 6 is 0. Now, is 0 a number? It is. So if this was a horizontal asymptote problem, which it's not, because I didn't put the words horizontal asymptote, but if it was a horizontal asymptote problem, then y equals 0 would be my horizontal asymptote. Technically, my left horizontal asymptote, right? Okay, but probably it would be the same for both. So in a problem where they give you the limit, don't try the other one. If it asks you for negative infinity, just do the negative infinity. If it asks you for an asymptote, that's when you want to do both. Just to get it in your brain that you really want to see the right side end behavior and the left side end behavior, although usually they give you the same answer in problems like this. Okay, so let me show you one more. There's one more type of a weird situation you're going to get back from the very beginning of the examples. Okay, so the very beginning of the examples, you're going to have the same situation. This is example 7. Okay, so example 7, you have your regular limits or you have an asymptote. So either way, I'll do negative infinity again, but it could be positive infinity or negative infinity. And this time the degree in the numerator is higher. Okay, so the degree in the numerator is higher. So I get this. And then let's say I had 8x to the second plus 4x minus 12. So I look at this and I say divide by x to the second, right? Numerator and denominator. So this is what's going on in my head. That's because I'm approaching infinity or negative infinity. Okay, so this is 3x to the 5th over minus 4x over plus 6 over 8x to the 2nd over plus 4x over minus 12 over. And it gets kind of irritating because you're like, why am I showing this step? We're showing the step because we're trying to do it the official way. Okay, because we need all the tools in case problems get hard. Okay, so we're not looking at taking any shortcuts at the moment. I'm going to divide everything by x to the second. Okay, shortcuts don't help you when the problems get more complicated. Okay. Okay, do I have an x? I do. I need the limit as x approaches infinity in the front. I reduce. So this is my dividing step. And then I need my reducing step. Okay, and the AP test, most of the points on the AP test, well, half of the points on the AP test are partial credit. Okay, so you do have to show your work. So work is going to be important. So, and your calculus teachers, you're going to make them crazy if you don't show work on their homeworks. Okay, usually we spend this time having you guys practice showing work well so that when you get to calculus, your calculus teachers aren't hysterical. Okay, because they're going to be hysterical if you don't show your steps. Okay, so you've got to make sure you show legible steps so people can understand what you're doing. Okay, you're too far in math now where it's not about answers anymore. It's about communication. Okay, communication and people being able to follow your steps. Okay, so let's look at this. So 4 over x, as x approaches infinity, that goes to 0. 6 over x squared goes to 0. Because that's what? 6 donuts, a billion squared people. 12 donuts, a billion squared people. Billion squared people. So I'm a little concerned with my 3x to the third because that's 3 times whatever, a million to the third. Ew. So this is what I'm thinking in my head. That's not 0. Okay, so let me regroup. I still have 3x to the third over 8. Everything else is gone. I still have an x, so I guess I still need my limit. And then we have to treat this back to end behavior, same idea as what we had before. So over here, because you're really not supposed to be substituting in negative infinity, but basically this is what I'm thinking in my brain. And often you write it on the side. Okay, but you don't want to write it officially in the middle of your steps of the problem. You're not supposed to plug in negative infinity. Negative infinity is not a number, it's like an idea. So negative a million to the third over 8. Okay, so let's see, you guys, can you tell me what negative a million to the third times 3 over 8 is? Yes. Oh, you kids are so awesome. Okay, so I'm not going too fast at least. Maybe some people put me on pause and put me on, but that's good. Nice. Nice. Okay, so this is negative infinity is the answer. Right? Because this is like negative huge number. I'm writing over in the right in the bubble. That's negative huge number. Okay, so that's negative infinity. And then that's the answer to the limit problem. Now, in the back of the book, oh, it's so annoying. So the back of the book, I don't know what they were thinking. So sometimes they call this no limit. That is not correct. Do not do that. Your calculus teachers, the AP people, they will not like it. Do not call that no limit. Not sure why. There's like, well, there's no floor. It keeps going down, down, down. But anyway, yes. Oh, that was my next part. Is what if it's a horizontal asymptote problem? Okay, so good question. That's exactly what I was going to do next. If it's a horizontal asymptote problem, what you're saying is as you go left, you're going down. So where's your asymptote? Anyone have an idea? So what's my asymptote is if I go left, I go down. And let me show you where that is. Limit as x approaches negative infinity of f of x equals negative infinity. That's what we just got. So this negative infinity is a left or a right. So that's a left. And this answer is a y value. So negative infinity on a y value is down. That was like end behavior. So let me click on this thing. And what do you think? Where does it level off? Where does it level off like an asymptote? What do you think? Where does it level off? Anyone have an idea? Okay, let me scroll up. I'm gonna scroll up, and I wrote something specifically about horizontal asymptotes. So let me show you, and then we're gonna write this on this problem too. I'm gonna go up, okay, and let's look at where I put. Right when I was doing the horizontal asymptotes, I gave you a plan. Oh, I wrote it right here. So let me highlight this in blue. See where it says find horizontal asymptotes? Has to be a number to get yourself a horizontal asymptote. Is infinity a number? Is negative infinity a number? Are you leveling off? No, exactly. So scroll back down. So scroll back down. What this means is this means no horizontal asymptote. That's how you get no horizontal asymptote. Now, technically, I was only doing a left one, right? Not a right one. So I was only doing a left horizontal asymptote on that. Okay, and let me just show you, because it's kind of interesting. So let me just show you a future problem. Okay, so let me have, this is y equals e to the x plus 4. So let me draw you a little picture of e to the x plus 4. Looks like this. Okay, so look at that picture. That's this graph. What if I was looking for horizontal asymptotes and I was doing it the official way? I would write limit as x approaches infinity of e to the x plus 4. And then I would also try x approaches negative infinity of e to the x plus 4. Now, what if I plug an infinity into x? So I get e to the infinity. So that's like 2.7 times 2.7 times 2.7, an infinite number of times. Okay, so that's infinity. So what's infinity plus 4? Still infinity. So this is infinity. So if you get infinity, I'm supposed to get a number. So this is no horizontal asymptote. I need a number to get an asymptote. Now, is that the right side or that's the left side? This is actually the right side. I'm going to write it right under the infinity. That's the right side because the x is approaching positive infinity. So I'm going to do this in yellow. So on the right side, it's going up forever. So that's not an asymptote. But there is an asymptote on the left side. If you look at the graph, on the left side, as I go to the left, I'm leveling off at 4. So I'm expecting my answer is 4 algebraically as well as graphically. But the left side asymptote is not the same as the right side asymptote. You do not have any of these questions in your homework. They're all polynomials. Okay, but it's interesting. And then some of them have already divided by the highest power of x. So you're like, it's not really like this fraction that she's talking about. And then you just do it like examples 3 and 4. Yes, so it's none. None on that side, exactly. So there's no horizontal asymptote on this one. Oops, let me erase that. So there's no horizontal asymptote on the yellow one. And then what about this one? So this is kind of cool. What's e to the negative infinity? So I'm thinking this in my head because I'm not really supposed to show the substitution, but it's okay. Usually teachers, as long as you write it off to the side and not in the middle of the problem officially, they don't mind. So this is 1 over e to the infinity, right? Because that's what negative exponents means. So that's 1 over a huge number, right? So I've got one donut and I've got an infinite number of people, a bigger infinity than the e, right? So I've got an infinite number of people. So what's 1 over an infinite number of people? Okay, so what's one donut and an infinite number of people in the denominator? Crumb, exactly, so 0. So this one actually goes to 0, which is weird because e to the x went to infinity. But e to the negative x actually goes to 0. So you get 0 plus 4, and 0 plus 4 is 4. Now, is 4 a number? Yes, 4 is a number. So y equals 4 would be your horizontal asymptote. Now, technically, you just call it a horizontal asymptote, but I like to call it a left horizontal asymptote, because if I was graphing, I know that it's on the left and not on the right, because usually the asymptote is on both sides. So it's very odd to have one asymptote and then the other side doesn't do it, but that's what E's happen. So anyway, that's the end. That's just a little advanced notice. So you'll like this homework. It's pretty nice. It's a lot of dividing in algebra, but try to be thinking of what's going on. If you want to use Desmos or your graphing calculator to try to graph them after the fact, so you can kind of see like what the graphs look like, you could do that too, just to give yourself an idea of the graphs, but you definitely don't have to. If it says, there's one that says use a graphing utility to verify what the horizontal asymptotes are, I wouldn't do that. Okay, so that's all you're doing. And that's kind of a nice homework. Okay, and then the other limits are different, but it'd be nice to do this before you watch the other video if possible. Okay, so really you only have 2 required homeworks every week, which is the new stuff from chapter 12, and then the Friday ones, which maybe you did during the break, maybe you didn't do them or not. They are optional, but we wanted to be able to let people who did them, we wanted to put it in, but we didn't want to overwhelm you. So, you know, we were kind of arguing, all the teachers and me. Okay, so there's 4 of us, and we don't always have the same opinion. I wanted to assign 5 homeworks a week, so 4 homeworks a week, and then I was down to 3 homeworks a week. So I'm the one for the more work, but you guys, I'm the one who made the original math analysis calendar, so it's my fault no matter what. Okay? Okay, well, thank you so much for coming, you guys. I know we only have 4 people left, but I appreciate it. I much prefer teaching to you than teaching to the puppies. Okay? So I'll post this for everyone else. It'll take a little while. And then they can watch it tomorrow if they want and do the homework. Or this is actually watch the video on Monday, do the homework on Tuesday, then watch the video on Wednesday, do the homework on Thursday, and then Friday is optional. But if you already did it, that's fine. If you have other homework, don't worry about it. Okay. Remember, we put NA in things you don't do. Okay, and your grade can't go down. Okay, but we want you to still learn it, so that's why we're still teaching. Okay, so hopefully you do it. Okay, but really, I mean, you gotta worry about your grades in all your classes, not just this one. Okay, so anyway, fun to teach to you. I'll talk to you guys later, okay?